In this example, we will be using the addition rule for the general case. So this is the general addition rule. So the probability that Cass is accepted to UC Berkeley is 14%. And let's suppose it's known that the probability Cass will be accepted because Cal State University Hayward is 84%. And the probability that Cass is accepted to both colleges is 11%. So what this means is that by both, we mean the probability that Cass is accepted to UC Berkeley and Cal State University Hayward. So the question is, what is the probability that Cass is accepted to UC Berkeley or Cal State University Hayward? So what OR means is, what is the probability that Cass is accepted to one or more of the schools? So in order to calculate this probability, we are going to use the general addition rule. And we're going to use the general rule because it's pretty clear from here that these events are not disjoint. So in order to use the general addition rule, I'm going to calculate the probability that Cass is accepted to UC Berkeley or Cal State University Hayward is equal to the probability Cass is accepted to UC Berkeley plus the probability Cass is accepted to CSU Hayward minus the probability that Cass is accepted to both colleges, so UC Berkeley and Cal State University Hayward. And that is equal to 0.14 plus 0.84 minus 0.11, and that is just 0.87. So in order to gain a little more insight into the previous problem, I wanted to construct the Venn diagram. And let's suppose that this box represents my sample space, so everything that can happen. And the circle on the left represents the event that Cass is accepted to UC Berkeley. And this guy on the right represents the chance that Cass is accepted to, represents the probability Cass is accepted to CSU Hayward. So we are given that the probability of being accepted to both colleges is 11%. So that is the area right in the middle that you see right here. So I'm going to fill that in. So this is being accepted to both colleges is this area right in here, the intersection of the two circles. Now, I was given that the probability of being accepted to UC Berkeley was 14% and Cal State was 84%. So if I know the probability of being accepted to both, and I know the probability of being accepted to UC Berkeley is 14%, then that allows me to figure out the probability of being accepted to UC Berkeley but not being accepted to Cal State Hayward. Okay, so in order to figure out this area, all I have to do is subtract. So in this case, I have 0.14 minus 0.11, and that is just 0.03. And that gives me this region right here. So that is basically UC Berkeley, but not Cal State Hayward. And now I can do the same thing to figure out the probability of getting accepted to Cal State Hayward, but not UC Berkeley. So I'm just going to subtract the probability of being accepted to Cal State Hayward, and I'm going to subtract the probability of being accepted to both. So this area right here, or this probability, is 0.73. Write this over here, that the probability of getting accepted to UC Berkeley and not being accepted to Cal State University Hayward is equal to 0.03. That's this guy. The probability of not being accepted to UC Berkeley and being accepted to Cal State University Hayward, okay, that would be this area right here. That's 0.73. Okay, and we could also look at the probability of, if you wanted, the probability of being accepted to exactly one college. So what would that be? So that would be the this probability plus this probability, right? It would basically be this area plus this area over here. Okay, so not including being accepted to both or neither. So that would be 0.03 plus 0.73. So that's 0.76. And how about the probability of not being accepted to either college? So neither college accepts Cass. And that would just be the complement of these areas that we have here. So that would be 1 minus 0.03 plus 0.11 plus 0.73, which would be 0.13. And that would be this region you see out here. Would be this sort of like outside region here. Okay, and you can see that all four of these numbers add up to 1. So Venn diagrams can be really helpful in figuring out all different types of probabilities. I also wanted to point out this probability we actually calculated in part A. This is actually the probability of getting accepted into UC Berkeley or getting accepted into Cal State Hayward. And we had used the addition rule, for the general addition rule, to calculate that, but you can also calculate it in this way also. Another question we would like to answer is, what is the probability that Cass is accepted to Cal State Hayward given that Cass was accepted to UC Berkeley? So this is a conditional probability. If we already know that Cass was accepted to UC Berkeley, what is the probability Cass was accepted to Cal State Hayward? The notation we would use for this is find the probability of Cass being accepted to Cal State Hayward given that Cass was accepted to UC Berkeley. In this case, we're going to use the conditional probability formula. So the probability of Cass being accepted to Cal State University Hayward given that Cass was accepted to UC Berkeley is equal to the probability that Cass was accepted to both, so Cal State University Hayward and UC Berkeley, divided by the probability that Cass was accepted to UC Berkeley. And remember that this is just our both probability, which was given to us as 0.11 or 11%. The probability of Cass being accepted to UC Berkeley was also given to us as 0.14. And so this is 0.78571, which I'm just going to round to 3 decimal places. So that gives me 0.786 or about 78.6% approximately. So if we know that Cass was accepted to UC Berkeley, there's about a 78.86% that Cass will be accepted to Cal State Hayward. The last question we want to take a look at is the following. Is the event that Cass is accepted to UC Berkeley independent from the event that Cass is accepted to Cal State Hayward? There are various tests that you can use. However, since in Part B, we just calculated the probability that Cass is accepted to Cal State Hayward given, so we just found this probability. And one test is we can ask ourselves is this probability the same as the probability that Cass is accepted to Cal State University Hayward? And this probability was given as 84%. And since this probability is not equal to this probability, we know that these events are not independent. So just to summarize, if the probability of A given B is not equal to the probability of A, then you know that your events A and B are not independent.